In last video, we learned that Gaussian elimination has three important steps, and the second step and the most important step is to convert the matrix in echelon form and row reduced echelon form. In this video, we learn about what is an echelon form and how to identify whether a matrix is in echelon form or not. A typical echelon form of a matrix look like this, and you can see that lower left corners are mostly zero and upper right corner can be non-zero elements. And if we divide a curve between zero and non-zero elements, we can see that there is a stair-like structure, and each corner of a stair-like structure there are non-zero elements p1, p2, p3. They are called pivots. So first non-zero element in each row is called pivots, and any element below the pivots must be zero. Any element in the left of the pivot also has to be zero. If we consider the matrix formed by the elements below and the left of the pivots, then it will be all zero except the pivots itself. Pivots has to be non-zero. For example, consider P3 here, then the matrix formed by elements below P3 and the left of P3 are all 0 except P3 itself. Now we will look at few examples and decide whether the matrix is in echelon form. We start with the first matrix and we look at each row first. In the first row, the first non-zero element will be pivot. So here 1 is the pivot and any elements below that is 0. Now we go to the second row and the first non-zero element is the pivot, that is 3, and if we consider the submatrix formed by elements below 3 and left, then only element that is 0 is 3 itself. In last row we can see that there is no pivots, so we don't have anything to do, hence this matrix is in echelon form. Now we go to the second matrix and we start with again with the first row. We can see that the first element is a non-zero element, so pivot, and anything below that which is 0. Now we go to the second row, we see that third column we got a pivot, and the matrix formed by elements below it and the left of it is all 0 except that. And again, in the third row, we can see that all the elements are 0. There is no pivot in this, so the matrix is in echelon form. Last matrix has only one row, so we don't have anything to do. Whether it has pivot or not a pivot, it always will be in echelon form. Now we quickly decide some matrix not in echelon form. In the first matrix, we can see that in the first row, we get a non-zero element in the second column, and that is a pivot. And if we look the matrix below and left of it, we got a non-zero element except that pivot, that is 1. So this matrix is not in echelon form. Now we go to the second matrix. We start with the first row. First non-zero element is pivot. 1 is pivot here, but all the entries below that pivot is not all 0. We have a non-zero element, so it is not in echelon form. In the third matrix, we also have the same problem. The entry below pivot is not 0, so it is not in echelon form. Thank you for watching.